Okay, so in the previous video, I introduced the basic setup, basic idea of what we are doing in the regression model. So we are estimating two parameters, beta 0 and beta 1, and our data should be paired. So our data should include x and y, and they are paired. For example, it should be like when x equals to this number, excuse me, y must be y was this like this, and when x was like that, y was like that. So you have to have x and y paired and an observation of them. Oh, excuse me. And then so as a result, you are going to have beta 0 hat, which estimates beta 0, and beta 1 hat, of course, which are beta 1's estimator. And in the end, later, we are going to learn the sampling distribution of beta 0 and beta 1. And then the sampling distribution of those estimators enables us to do the basic analysis, like whether they are unbiased, and what is the most efficient estimator, and what is the confidence interval, what is the t-statistic, what is the p-value, what is the, whether you can reject a certain hypothesis or not. These things can be done on these estimators, right? And then the question is, how do we estimate those things? How do we calculate those estimators? That's the key, and the method is called the ordinary least squares method. Ordinary least squares estimation method. So OLS, usually we call that OLS. By the way, we call this ordinary because that's ordinary. It is standard things. Later, when you learn more data analysis tools, there are generalized least squares, weighted least squares, like indirect least squares. There are different types of least squares methods. So relative to them, it is ordinary. It is basic method. So we call this OLS. I am going to explain how to calculate that later, after I show you how to use the results. I'm going to show you the results first, and then explain how we can utilize those results, and then come back and explain how those are calculated, because it's related to the usage of the results. Okay. Okay, let's go back to Excel. Go to Excel. Here, this is the data. I showed you 12 outputs, productions, and 12 costs for each of them, right? They're paired. These are paired, okay? So what's interesting here is, first, it's weird. So in January and in February, the production amounts are different, but their total costs are the same. That's because there are random errors. Some random error happened. So when you produce 3, the cost must be higher than 2, but they are the same due to, like, maybe there was a positive error here or negative error here. Similarly, here and here, 2 months have the same production, but total costs are different because of random errors. So anyhow, this is our data, another pair with the same production with different costs. So first thing I'm going to show you is how to draw scatter plot. So go to insert tab, and you may click here, but this is the scatter plot. Insert scatter plot, click here, click this. That's it. Okay, this is the same graph you see in the slide, and I will show you how to make a trend line. Pretty simple. Here, plus, and include trend line. That's it. This is how you draw a trend line. Of course, this trend line is based on the OLS estimator, right? So drawing a trend line is to estimating an intercept and a slope. So that is based on the OLS. It is really quick to the computer, so instantaneously you can generate a trend line. Okay. Okay, making a graph is not a big problem. I believe most of you must be better than me, I guess. And now I'm going to show you a regression toolkit. Go to Data tab, and click Data Analysis Tool. And then here find Regression. Here I click Regression, okay? And Y. So remember, Y is the outcome. That is generated based on X. So that is cost. And X range is output. And labels, the first row is labels. And you may have, so line fit plot. If you click this, you are going to have scatter plot with trend line. So just let's try this. Okay, then if you click OK, then you have a plot and some tables. First, let's look at the plot. This is the same thing, but the difference is the trend predicted cost are dots, not a line. But if you connect them with numbers, like where do I put the line? Oops. So, excuse me. So if you make them a line, they are exactly the same line as the scatter plot, right? This is the same graph. These two are the same graph. So the predicted costs are the trend line. And here, let's look at the tables. Let me ignore this part first. Ignore that part. And we are going to look at those top three panels. Top three tables. First, this table is the main result table. So we have intercept beta 0 and coefficient of output beta 1. So this is fixed cost and this is marginal cost. And those are estimated point estimates for those two parameters. So our estimate is that the fixed cost is 8 and the marginal cost is 2.3, right? It may have random error. So the random error is the standard deviation of the random error is calculated in this column. So standard error is the standard deviation of the estimator. That is calculated here. So, okay, so that's from these two, we may think about some normal distribution. Assuming normal distribution, you can think about a lot of, you can implement all those methods we learned in chapter 9, 10, like 8, 9, 10, right? So for example, these two are basically the same thing. I will erase them. This is lower 95% confidence limit, upper 95% confidence limit, and this is for beta 0, and this is for beta 1. So confidence intervals are calculated based on these two numbers. Point estimate plus minus z alpha over 2 times standard error. So we have everything. Alpha is given by 95%. So confidence intervals are given. Also, now this t statistic and p-value are based on the hypothesis that beta 0 is 0, beta 1 is 0. So we would like to test if they are 0 or not, right? If you assume they are 0, then you calculate the t statistic. T statistic is the difference between the estimator and your belief divided by, standardized by the standard error. So you can calculate all the things. And then applying that to normal distribution, you can calculate p-value, right? So p-value, I will change it to number. Then p-value is 0. Very, very you are going to reject the belief that the belief that beta 0 and beta 1 are 0. Of course, costs are not 0. Cost parameters are not 0 here. And later, we are going to study these things. These tables. The goal of this chapter is to understand some of these things. And also, we are going to utilize this table. Something we can understand first here is the number of observations. Number of observations is 12, right? And then all the other things will be discussed later, right? Some of them are too difficult, is beyond what I can show you now, but later we are going to use them. Okay, so I used Excel, and this is the result you are going to see, and we will study column by column, right, from this table. So this was a brief video, and later in the next video I will show you how to utilize those results first, right? And then we will learn how to calculate these guys, and it's kind of reverse order, but I think that is more efficient way of learning. Okay, thank you for watching, and see you in the next video.